session number 2, everybody, of the 4th annual Technology Matters Marathon. My name is Kalia Garrido, and I head up marketing and events here at Great Data Minds. I will probably be abbreviating my intro a little bit as we go throughout the day, because I see a lot of the familiar names that were on with us at the first session. But if you don't already know us, if you're signing on new, Great Data Minds is a collective of passionate data activists, and we are on a mission to modernize the world of data. We do this via our services arm, which is called Great Data Minds Innovation Labs. And that's where we do the deployment of our critical data projects and our strategic planning, things like that. And then also on the greatdataminds.com side of the house, this is where you find yourself today. This is our community and our content, our education, and our fantastic events, just like the one we are presenting you with today. So a little bit of housekeeping as we get cooking. This is a webinar, so of course your cameras and microphones are off, but we highly encourage participation. You've got a number of ways you can do this. We have the chat going. It's very active. We saw some fantastic lines of questions happening in the chat in the first session. You've got a Q&A. If you feel like just spicing it up and using that instead, you can do it that way as well. And then at the end of each session, we're going to hold a little bit of time to answer some questions, and we could do them live there. So again, encourage participation. The session for today, all of the different sessions that we're going to go are going to follow the same kind of format. We do this little banter and bad jokes for just a couple minutes to totally delight you before we get started. And then we introduce our company, which I'll do in just a second. We're going to be hearing from DataRobot up next. DataRobot will do, 15, 20 minutes of an intro to the company, answer some questions that we might have top of mind, and then we roll into, 20 minutes or so of a demo. The whole thing takes about 45 minutes. Like I said, we leave a little time for Q&A at the end. Take a short break. We do it all again. Speed dating for cool tech. That's what this is today. So very quickly, again, my partners in crime, Julie Burrows, she is our esteemed CEO, and Mike Lampa, he is our Chief Analytics Officer here at Great Data Minds. Now, on the other side of the camera today, the folks that we have with us are I feel like it's a little bit of a special guest because I did not know that Nicole LeBlanc was going to be joining us today. But Nicole is my counterpart at DataRobot. She is the Director of Partner Marketing at DataRobot. And we also have Max Duggan Knight, who as of yesterday announced his promotion to Senior Data Scientist at DataRobot. So congratulations on that.
Congratulations.
Thank you.
And today, he's going to share more about the company and the tech that has been honestly out front of the whole AI movement for many years. It's like, I feel like the rest of the world's catching up with the stuff you guys have already been doing.
Yep, I agree with that.
Absolutely. Yeah.
We had our aha moment on this one, didn't we, Mike?
We did, and doubled down on forming a great partnership too. Julie, our aha moment around this product and platform was it truly is a complete AI ML lifecycle product. And again, just like we were talking about earlier today, we believe in that product management mindset, and DataRobot brings that product management mindset not only to the data components that have to be conditioned within the platform, but the analytic modules themselves are products that go through a life cycle. I love that. I mean, this is a fantastic platform. And a couple things, Max. I know DataRobot is incredibly good at enabling machine learning exploration, development, deployment at scale for organizations, including enabling the non-degreed, non-statistician kind of business analyst. But I got the impression that this is not only enabling citizen data scientists, this platform. I'm hoping we'll get a chance to talk about that today too. Julie, did you have any other item you wanted to share?
Mike, I like to tell stories because I'm from the South. So I love it. We always get pushback. I don't know, Nicole, you have any input on this one, but when we go to the head of data science, they are always like, oh, we don't need this tool. We don't need this tool. And it's funny because we were working with one of the top managers of data science, one of the oil and gas groups here. She's now with Amazon, believe it or not. And she's a buddy of mine, and we had the DataRobot hands-on last year. And I said, come on over. She goes, I don't believe in that stuff. And we've heard this before. She goes, I don't believe in that stuff. And I go, okay, well, I haven't seen you in a while. Why don't you just come over and have lunch with us and at least give me feedback as to why? And she goes, okay. So she sits down next to me. We hadn't seen each other since before COVID. We were happy to see each other. And I'm sitting here kind of monitoring, the chat and everything. And all of a sudden she leans over, she goes, anyone that has Excel on their desktop should have this tool too. And I went, are you kidding me?
Yeah, right.
And she said, no, not at all. She goes, I truly believe in this. And so I think once the data science, in that same event, we were talking, and one of the reps for DataRobot said, why wouldn't you want your data science group to bring this tool in and govern all of these great models and thoughts that are coming out of the citizen data scientists? So it's a big aha moment for us. And I know DataRobot's being used. Kroger has 100+ people doing logistics and supply chain and stuff like that using DataRobot. So we're seeing it becoming more and more prevalent every day.
All right. With that said, I'm going to turn it over to you guys, Max and Nicole.
Yeah, thanks so much. I couldn't agree more with everything you said. I think, Mike, to your point, collaboration is still critical to this, right? Like people of different skill sets, like you're talking about, Julie, from business analysts, data engineers, IT folks focused on production at scale. Collaboration is going to be part of data science and machine learning forever. But especially in our most recent 9.0 launch, we have a real renewed focus on empowering and accelerating data scientists who may prefer to work in code, may prefer to work in low code. They can use our hosted notebooks to build their workflow out in repeatable code in a notebook. So that's just kind of one example, but in general, the theme is full control for data scientists who want that, and acceleration to really speed up the experiment lifecycle. Because as we know, machine learning is a very iterative process. No one, I don't think, has built the best model on their first try, or if they have, I would like to talk to them.
Yeah,
that's rare. So experimentation is key, and I'm going to talk about that. So I'm going to just go through a couple of slides to kind of talk really quickly about some framing, and also to address, I think, something that is probably on a lot of people's minds today, which is generative AI, because this is crucial, right? We can all see the impact that that's already having. So let me share my screen and we can jump right into it. All right. So generative AI is already moving very fast. Moving very fast, right? In the matter of 3 short months, this has become something that is like dinner table conversation, right? We can see this timeline here, just how quickly this is moving. And companies are playing catch up, right? How do we benefit from the value that this new technology can create? And that the speed of it is just quite remarkable. And it is really impressive, right? We've probably all experienced this firsthand because it is absolutely everywhere these days. And this is almost out of date now, this slide, given this is a few weeks ago, a month ago, but the Balenciaga Pope that I, for one, absolutely thought was a real photo the first time I saw it. But it is not. And it's doing impressive things, right, that we can all see immediately. But figuring out where the value is an important next question. It can be wrong, right? We know this as well. So sometimes the information it provides is not accurate. Something to be aware of as I kind of continue on this conversation. And it can create huge risk. So these models, the ones that we're used to using, like ChatGPT, are largely black boxes, right? There are pieces of this we don't understand how exactly they're working, and exposing these models to confidential data can carry all kinds of risks. There are risks in different parts of this. Basically, because it's so new, we don't understand all the risks, and so that's something to be aware of. And DataRobot is bringing an approach that we have used for 10 years for predictive AI to start thinking about generative AI as well, meaning that we sort of, data science kind of started with model-driven AI. If you think about like Kaggle competitions, right, competing basically on a set data set, who can create the best model, the highest accuracy. And then data-driven AI was a stage where we were, kind of focused on what data can we get to improve accuracy and think about how to create the best machine learning models. But ultimately, the objective with all of this is creating value, right? So that is where we need to work back from. How can these models deliver value? And that's true for predictive machine learning as well as generative AI. And today, generative AI is additive and enhancing predictive AI use cases. So this is one arena where DataRobot is really innovating and pushing the boundaries of the product development. Is how can we use generative AI to improve our predictive AI use cases, like your typical classification, regression, anomaly, unsupervised learning as well. And this can help in a number of ways, right? Personally, I don't know if I'll ever write code again without generative AI's help, right? That for anyone who writes their own code, that's the transformative technology. It can also help you interpret model insights. It can help you enrich your training data, and we need to monitor and govern these large language models that everyone's excited about. So all DataRobot's experience when it comes to models in production is going to be crucial for that. So finally, last slide, and then I'm going to get right into the demo. This is how DataRobot thinks about the machine learning lifecycle. There's really two buckets. There's the ML experimentation, which I mentioned earlier, right, as an iterative process. And what DataRobot does is it brings automation to data scientists and other personas to be able to experiment rapidly and get to insights quickly and get to that high quality model faster. Mm-hmm. And then once you've got your high quality model, getting it into production, right? Deploying it at scale to be able to drive business value. And you can see there are lots of integrations sort of on both sides of this equation, because we know we're not going to be the only technology you use. We need to integrate with wherever your data lives on the left side here, and wherever your predictions need to go to actually drive value on the right-hand side. All right, with that, I'm going to jump into the demo and start. We're going to look actually at DataRobot itself. So just give me 1 second. So this is the DataRobot start screen. This is where we bring data in, right? And you can bring data in from just about anywhere, right? You can drag and drop a flat file in. You can connect to your data store, like we saw in the last slide, with various connections to wherever your data lives. You can add your data connection and then bring in different tables and start modeling. And we will integrate really closely with those data stores because this is an iterative process. You're going to want to try different data sets, different tables. You're going to want to join tables. That's all made really easy. What I'm going to do right now is drag and drop a CSV file from my other screen into DataRobot. And as DataRobot starts analyzing that data and getting it ready for modeling, I'm just going to show you quickly what this data set looks like. So we understand the use case we're looking at here. This is a data set that some of you may have seen before. It is a data set where we are trying to predict readmission of hospital patients, okay? Each of these rows is a patient, and we have some information about the patients. We have, demographic information about the kind of diagnosis they've received, health conditions, and all the way on the right-hand side, we have some doctor's notes. So this is free-form text that we're going to let DataRobot pre-process and model for us. And then this is our target variable, which is, was that patient readmitted within 30 days of being discharged? This is an important use case. If anyone works in insurance or healthcare, this may resonate. There can be important implications if a patient is readmitted in that kind of timeline. But even if you're not familiar with this use case, you can imagine this applying to many other kinds of use cases. We want to know what's the probability of a given patient being readmitted or not. All right. So if I scroll down here, we're going to start to see DataRobot getting this data ready for modeling, right? First of all, it's going to automatically identify the different variable types we've got in here. We have some categorical variables, some numeric. We saw on the right-hand side there, we have some text features, and we have our Boolean target variable. We can click into these features and understand the distribution of the different variables. This is the kind of thing data scientists do as they're getting ready for modeling, but DataRobot is speeding it up, automating it, and making this information readily available. And then all I need to do is tell DataRobot what that target variable is. It's that readmitted column, and it will come back and say, okay, this is clearly a binary classification problem. Here's the distribution of the different classes. It's going to recommend an optimization metric, and I can hit that start button and start modeling now, right? So that's kind of gives you an idea of how quickly you can move. But before I do hit that start button, I want to point out as well, because we touched on this earlier, right? The idea of full control for data scientists, for folks who know the data really well and may know specifically how they want, some decisions they want to make about this modeling. If you start digging into the advanced options, you can control everything from how this data will be partitioned and validated to how you want to control for things like bias and fairness, whether we want to incorporate time series modeling into this, and many, many more things that I won't go into all of because that would take a long time. But the point is, if you know specifically what you want to do, you can have full control. And what I usually like to do personally is start with the default settings, right? As a baseline. Let's try that. DataRobot will create some very, very accurate models even off the beginning. And then I'll iterate and I'll tweak some things and I'll see if I can eke out some more accuracy. What I'm going to do now is I'm going to set this to autopilot mode. There's a few different modes you can run in, and this depends on sort of how long you have and how many different modeling approaches you want to try. I'm going to hit the start button, and DataRobot will start going through the steps that a data scientist is used to doing in, say, a Jupyter notebook or in Python somewhere, right? But by hand and with more risk of error, right? This is one of the key points of emphasis here, is that you can move quickly without risking costly mistakes in DataRobot, because our data scientists have spent years ironing out any problems in the process and setting very, enforcing data science best practices in this modeling process. Mm-hmm. And you can follow along on the right here what's happening, right? Setting the partitioning, doing some feature analysis, and then finally this step here, generating blueprints. This is where DataRobot is on the fly coming up with modeling approaches that fit our data, including the final machine learning model that's going to be trained, but not just that model, also all the pre-processing steps required for those different data types. So if you're a data scientist, this will help you move really quickly. If you are a leader of a data science team, you can trust that the work your data scientists bring to you is going to be of high quality, and you can also probably have higher expectations in terms of how long it will take them to turn it around. You can ask for something in a couple hours rather than a couple weeks. And on the right here, you can see a few different of the modeling approaches being tried. So we have deep learning models, we have Python models, there are some DataRobot proprietary models. For the most part, this is open source machine learning technology. We know a lot of the innovation is happening in that realm, and our data scientists bring in that technology, those modeling approaches, and you have access to it immediately. So you don't have to spend your time reading academic research papers. You can trust our data scientists to do that. I have 20 modeling workers, which you can see up here on the right-hand side. You can think of that like compute horsepower. And if I bump that, if I say I want to use all 20 of them, that's going to let me train 20 models in parallel. So again, just kind of reiterating, not to be too repetitive, but you can move very, very quickly, right? This is as opposed to trying something, looking at the accuracy, going back and starting again. We can try a lot of things in parallel and get to that answer very quickly. All right. I mentioned at the top that our 9.0 launch has really emphasized accelerating data scientists kind of regardless of preferred skill, preferred workflow, whether that's in this GUI or whether you want to use a code first approach. And this is all available using our API, right? We have a full REST API, a Python client, an R client, and most recently we've introduced our hosted notebooks. So you can see that tab here where I can, if I switch over to one now, you can do exactly what I'm doing with point and click, but you can write it in code. And this is just an example where I'm making some predictions on a deployed model and getting the results back. You know, it's very, very easy to set this up yourself. You just have to use you just have to, you know, put this one line and you're automatically connected to the API and then you're good to go. So some data scientists will prefer to work this way. And we also have some handy pieces in here like code snippet, which I find very helpful, right? If you know you want to do something that is kind of a frequent DataRobot task, we may have code that we can just plug and play in, so you don't have to start from scratch. All right, so that data, we're still training models on that data set. I'm going to skip ahead to a finished version of it. This might take, let's see, we've already trained 36 models. I think this might take another 7 to 10 minutes to complete all the way through. If that were, yeah, that seems about right. But I'm going to go ahead to a finished one so we don't waste any time and show you what this looks like once it's done, right? So now we're in the models tab and we're looking at, we have 65 trained models ranked by their performance in cross-validation. So these are models being validated on data that they were not trained on. And we can get a really good sense of how accurate these models are. And you can scroll down the list and see all the different modeling approaches that were tried, how their accuracy compares, and see that this one at the top won that competition and is already prepared and recommended for deployment. DataRobot is really, we do not like black boxes, right? And I kind of touched on this when it comes to generative AI, but there's a lot of risk involved when you don't understand what the model that you're using, how it actually works. So a big emphasis here is explaining exactly step by step how this model works, how we are dealing with each different data type, how that process data is then being passed into the final model itself. And clicking in here, you can see the specific parameters that are being used for this step in the process. And I can click into the documentation and immediately see some information about exactly how this was implemented. So there are no black boxes, and this is crucial, right? If you have a question about how one of your data scientists did something, this will all be in one place in DataRobot for you to come in and see for yourself. Now, there are a lot of tabs here to understand how this model works, and I'm not going to have time to go through all of them, but I want to just flag a couple key things. One is, if I go to prediction explanations, this is going to help us understand for a given prediction that the model has made, why was that the prediction? So in this case, what we're looking at is a row, a patient, that the model thinks is 92%, there's a 92% probability that this patient is readmitted. Right, very, very high. This is at the high end. This may be the highest one in the sample data set, in fact. And why is that? Well, number inpatient is 8, meaning that this patient was already a patient 8 previous times. So this is the most important feature driving that probability up. So we can give specific reasons and not expect people to just trust the model's predictions at face value, right? They're going to have questions if they're going to actually implement these predictions. So we need to be able to explain where they came from. Number of lab procedures was 73. And then we also have what the sort of nature of the discharge was. And because of this discharge specifically, that's contributing to a higher probability of readmission. We have some free form text in that data set that we saw. So we can also look at a word cloud to understand how specific terms are impacting the model's predictions. What this is telling us is that the more red a term is, the more it is contributing to a higher probability of readmission, the blue contributing to lower probability of readmission. And the size is just a frequency in the data set, right? So congestive and heart are terms that are contributing to high probability of readmission. And then we can take out valuable insights from information like this. And like I've said, understand how the model works using this kind of insight. All right. I'm going to touch on a couple other things, right? One crucial piece of this is governance. Machine learning is complicated, and for that reason, there will be lots of questions about exactly how decisions were reached and how models work. And in some industries, heavily regulated industries like finance, insurance, healthcare, you may even have regulators asking for compliance documentation, right? This is something we're seeing more and more often. And we have worked with some of our biggest customers in these industries to develop automated compliance documentation so that you don't have to have your data scientists spending time writing documentation, which I can say from experience is no data scientist's favorite job. And it's very time consuming. So you can generate a compliance document automatically for this specific model. And if I just give a quick preview of what it looks like, it has a table of contents here of everything that's involved in the model building process. We have information like that blueprint we looked at. We have information about the accuracy, visualizations about the feature correlation, and on and on. And it's customizable, but this is going to get you 90% of the way there when it comes to regulators looking for compliance documentation. So that can save your team a whole lot of time. All right. One other key piece of this, I guess, it looks like I've got a couple minutes, is understanding how good this model actually is, right? That's one of the questions. Before we deploy it, we want to evaluate it and understand. And one place to start for that is this tab, the ROC curve, which will give us a lot of information. And not to overwhelm folks, I guess one thing to point out is this confusion matrix on the right-hand side. This is going to tell us and because this is a classification problem, right? We want to predict true or false. This is going to tell us how those predictions would actually compare to the holdout set, 20% of data that was not seen by the model at all. How would we do if we were predicting on that holdout set in real life, right? How many true positives will we have? How many false negatives will we have? And so on. And you can change your probability threshold here, and it will change how those numbers are allocated, right? So if I want to be even more, maybe I want to be more conservative and only predict that a patient will be readmitted if the model thinks they're 60% likely to be readmitted. And if you watch those numbers on the right, when I change it, they'll change, right? Because now we've set our threshold differently and we're allocating those numbers differently. This can be very important to understand before you deploy a model. Understand how these different outcomes are going to be affected. And you can even add dollar value amounts to these different outcomes. So, circling back to value-driven AI, if we think about maybe there are specific fines associated with a patient being readmitted. So if the model thinks that a patient will be readmitted, maybe it will be, if the model gets it wrong, right? We are not worried about a patient being readmitted, but turns out that they actually are readmitted. Maybe we're fined $100, and maybe if we correctly prevent readmission, I'm making these dollar amounts up, but you can imagine that if you have your business analysts and your stakeholders involved here, we can assign actual dollar amounts to these different outcomes. If I save this payoff matrix, then one of the things I can do is choose to maximize profit in this to set this threshold, as opposed to maximizing something like F1, and that would push the threshold all the way to the left there, just because of the kind of silly way I filled out those dollar amounts.
Mm-hmm.
But again, the point is we want this model to be delivering value. We need to understand the value that it's going to generate before we put it into production. And then once we do put it into production, we need to monitor it carefully, which is where I'm going to go next. So if I go to the predict tab, this is where we can start to get into how we actually get this model into production and start making predictions. Packaging a model like this up with all those pre-processing steps and all that whole pipeline that we saw, the blueprint, right? That's a non-trivial task if you're doing that yourself, if you're doing that in Python or something. And it usually involves multiple skill sets. You're not just going to have your data scientists involved. You may need folks from IT. You may need someone with specific ML ops experience to contribute to packaging this up and serving the model in a useful way for the business. So because that's so complicated, often models just kind of sit there and don't actually get deployed for weeks or months at a time. So you invest all this energy and money in developing a model, and then it doesn't go anywhere and doesn't actually drive any value. So DataRobot makes it very easy to package this up, right? All I need to do is set my threshold. Maybe we want to choose that maximize profit threshold that we landed on earlier. I set up new deployment, and with just a couple of clicks, I will be able to package this up and deploy it to our prediction servers. I have a couple of decisions to make about the governance of this specific deployment, and I hit deploy model, and it will move on over to the deployments tab, where we have a snapshot of the health of all of our machine learning models in production. Each of these rows is a machine learning model running in production, and we can see these models are being used actively. These ones at the top anyway are being used actively to make predictions. We have information about the health of this model in production. And if I click in here to just an example one, we also see the governance piece of this, right? It is crucial that you have a handle on how these models are working and what is going on with them, how they were created, when they were deployed, all that kind of information. Because once these models are deployed, these predictions are out in the wild making decisions, helping to inform decisions, right? So you as a leader of a data science team or a business leader may get questions, and it's crucial to be able to go somewhere and see, okay, this model, it was trained on this specific data set. This is the model that's deployed inside this deployment. I can click into the project and see all those insights we just looked at a second ago. And I can also click through the logs here to see a paper trail of who did what when. So who deployed this model originally, on what date, when was it replaced, for what reason? And you can answer questions very clearly that way. In this case, it's all been me creating, deploying, and replacing it a couple times. And again, lots of tabs here. I'm not going to go through all of them because I think Mike or Julie would jump in and cut me off because it'll take too long. But I do want to point out a couple just while I have a couple more minutes here. One that's really important is data drift, right? We know that when you deploy a model, you cannot just trust blindly that this model's accuracy will continue to be as accurate as it was during validation forever, right? It won't be. Models decay over time. That's just the way that machine learning works, and it's because of data drift. The world changes, so data changes. And for example, this is a common example that we talk about is our customers who had data drift monitoring set up were much more proactive when something like COVID hit, right? COVID was something that affected almost every industry, and regardless almost of what your model was predicting, you might see the impacts. So the customers who had data drift monitoring set up were proactive, could retrain their model on newer data, including data from the pandemic, to keep their accuracy up. Whereas if you didn't have data drift monitoring, your accuracy would suffer, and all kinds of downstream effects would happen. So how do we think about data drift in DataRobot? We track every single feature in that data set to see has it drifted compared to the training data. And you can see these features, each of them are a dot on the scatter plot. You can look at each of them and understand sort of how far they drifted, what they are. They're ordered by their importance to the model on the x-axis, and how far they've drifted on the y-axis. So what this is telling us is the majority of our features have not drifted very much at all. They're that green color that is telling us we're good. But we do have this one up at the top that is at risk. The reason it's not red is because it's not so important that it's in this quadrant. But we will get notified automatically when a feature drifts above this threshold, and then we can make a decision. Do we need to retrain this model on newer data, which is usually the best next step, which you can also automate in DataRobot. So this feature has drifted. It's saying that it's at risk, meaning basically we can no longer be sure that our accuracy will be as high as we saw during training and validation. We can also monitor accuracy over time. So if you're in a situation where you make a prediction and then you get those actual values back after the prediction, were we right or were we wrong? In our case, was that patient readmitted or not? Our model thought they wouldn't be. Were they after 30 days? You can upload that data and track your model's accuracy over time, which is important to understand how accurate your model is for all kinds of data science reasons. But it's also important for getting buy-in from the business, right? If you have folks who have questions about how a model works and maybe they're skeptical about how accurate the model can be, you can point to a track record here and say, the model has been this accurate for this amount of time. It's been in production making actual predictions. Here's how it's done. All right. And I'm going to then skip to the predictions tab, which is how we actually make predictions with this deployment. So you can just drag and drop a CSV file in here with rows and get back a probability for each patient to say how likely they are to be readmitted. Most of our customers tend to use the API endpoint that is automatically attached to any of these deployed models. You can make batch predictions, you can make real-time predictions. We're going to prepare that code for you to be able to access this endpoint and make predictions really easily, where you basically say, I want to take in data from here, I want to write it out somewhere else, and then you can make predictions easily. You can also set up what we call job definitions. If what you want to do is make a regular prediction job, right? If I add a job definition, what it's going to ask me is, where is this data coming from? Maybe that's a specific snowflake table, right? This is where our prediction data lives. Mm-hmm. Where do we want to write it out to? You know, in my case, what I like to do is have another snowflake table sitting right next to that prediction one, but this has the results. So read from one, write out to another, and just do that automatically every day, every week at a specific time. So when someone comes to your data scientist and asks for a new set of predictions, they can say, oh, it already ran. It's in that table, and just point them to the table. It runs every whatever it is, every day at a specific time. All right, I think I have probably talked enough, and maybe I will see if there are any questions before I hand it off.
Yeah, there are.
Great job, Max.
Yeah, awesome job. There are a few questions that have come in. The first one, Max, is around the topic of data wrangling. Can you give us a feel for, within the DataRobot platform, when I have to do some kind of conditioning or curating, where does that data wrangling happen?
Yeah, that's a great question. And this is a big part of machine learning, right? Is getting the data ready. So DataRobot, like we said, is a full lifecycle machine learning platform, meaning any kind of data preparation you need to do for modeling, DataRobot will help you with, right? We will help, you can do feature transformations in DataRobot in this data tab that we were looking at earlier, where we can change the type of feature in here. We can join data sets and have DataRobot do automatic feature engineering for us, automatic feature engineering, automatic feature reduction. And also we have a really tight partnership with lots of different data vendors, but particularly with Snowflake. For those folks who have their data in Snowflake, you can dynamically connect to Snowflake and create data wrangling pipelines and then push that compute down into Snowflake. So that can add a whole lot of speed and make the, again, that data wrangling to model validation kind of circle, make it really, really efficient.
Nice, nice. Awesome. Another question is, how does DataRobot differentiate yourselves from SageMaker, AWS SageMaker, especially Autopilot?
Yeah, in some, I mean, I think one thing to say is that some of our customers use DataRobot as well as a lot of AWS solutions like SageMaker. So you can do things like deploy DataRobot models to SageMaker endpoints and continue to monitor them with our MLOps our models in production that we just looked at. A couple things I would say that differentiate DataRobot from SageMaker. One is ease of use. So DataRobot is as we just saw, it can be extremely easy to use for folks who may not have, say, a PhD in data science or have experience stitching together complex parts of this process. You don't have to worry about infrastructure. You don't have to worry about your compute costs. You can focus on the modeling piece and getting insights out of the data and moving really, really quickly. That's one of the real differentiators just for DataRobot compared to basically anyone else out there. And then secondly, I would say that our ML production side, that deployments tab we just looked at is really best in class, right? Automatically having data drift monitoring, accuracy monitoring, challenger analysis, that is not a trivial thing to set up yourself in most other places. So being able to kind of trust that the models are going to be monitored and governed with best-in-class enterprise-ready technology can go a long way.
Awesome. Thank you for that. So another question, I think you may have answered it, but I'll ask it anyway. Can DataRobot push code down into Snowflake like a user-defined function? Or does it, you always have to pull the data into the DataRobot panel?
Yeah, that's a great question. So the answer is yes. And there are a few different ways that can work. One is on the data wrangling side. So getting the data ready for modeling, you can push that down into Snowflake and do things like feature transformations and feature generation engineering in Snowflake itself. Sometimes that is the most efficient way to do it. And then on the other side, once you have a model created and you want to deploy it, you can export the model itself as a user-defined function and put it right into Snowflake to be able to score data in Snowflake. And that's really handy if you're scoring, billions of rows and you want very low latency, for example. Keeping the data in Snowflake can speed that up. So some of our customers choose to do that for that reason.
Gotcha. Yeah. And does DataRobot support exporting the models into the likes of a GitHub? So we could do software version control and.
Yeah, great question. Yeah, so actually one of the features that just came out at our 9.0 launch is a deep integration with GitHub and specifically for CI/CD GitHub Actions. So for those of those folks on the line who are used to a CI/CD software development process where you are making changes progressively to your code and automatically testing and deploying those changes, you can do that using GitHub to do things like make changes to a custom model that you've actually created yourself outside of DataRobot and then want to deploy in our production environment.
Okay, all right. And then back to the pushdown question, clarification. So both model generation and the actual triggering or servicing of the model, using the models, I can push those down into the likes of a Snowflake, so I don't even have to call the DataRobot API.
Yeah, you can.
Okay.
If that's your preference and you'd rather use the Snowflake compute, absolutely, you can push down the data preparation pieces, and also once the model's trained, push down the actual scoring. You can export the model as a UDF. A user-defined function in Snowflake and do the scoring in Snowflake itself.
Okay. Yeah, because the follow-on question was, I wonder how all the monitoring that DataRobot does gets affected if I'm pushing it down into database.
Yeah, and that's a great question. So you have a range of options when it comes to the monitoring, but you can monitor models that are exported outside of DataRobot. We have an agent an agent technology that basically fits right next to your model and reports the monitoring statistics back to DataRobot. So you can still go into that dashboard and see things like data drift, but the model is actually running outside of DataRobot. That's possible. And you can also export scoring code, which is just the code for with the specific scoring instructions, which is the most lightweight way of doing scoring. Does not come with monitoring. But if what you want to do is like score really large data sets at the lowest latency possible, that can be the right answer.
Okay, very good. Awesome. I think we covered most of them. Great job. And
Good
I
job,
love
Max.
this technology.
Now we know you got the promotion.
Yeah.
I will.
Proof in the pudding, right there.
Right,
one other comment too. You have several advocates on the chat line, reinforcing to the audience that they love your technology. So, yeah.
Hey, Mike,
Glad
did you
to
get
hear
that last one comment over there? DataRobot supports or uses genetic algorithm feature question?
Yeah, a genetic algorithm or feature selection. Does DataRobot support that? So, like, I don't know.
Genetic algorithm.
Like, I don't know if we're talking about genetic sequencing or what. Maybe
we can take you offline one if you want us to.
Let us.
Yeah, I have to look into that.
Okay.
Yeah.
We will definitely take that offline one, and we will get an answer to you and your colleagues that are on the call.
Cool. Thank you, guys. You're always so
great.
good to us. You're
Thank you
always doing
so
this for
much.
marathons. Thank you. Take care. We'll see you at ThoughtSpot's up next. See you guys in a little bit.
Okay.
Yep, ThoughtSpot's coming next. We have about a 10-minute break. We'll get on the line just a couple minutes early before we kick it off with our third session of the day, which will be our friends at ThoughtSpot. So stay tuned for more.
Yeah, the non-technical technology, right, Julie? We'll see you guys in a minute.
Bye.